In this video, we'll be determining function, domain, and range from equations. Our directions are: decide whether each relation defines a function and give the domain and range. The first example is y equals 2x minus 5. Now this is a linear function. All equations that can be written in the form y equals mx plus b define linear functions. So this is a function. The domain on linear functions is all real numbers, and we show that in interval notation from negative infinity to positive infinity. Notice that when you use a left boundary of negative infinity, you need the open parentheses because you don't have a definite number there. And then a right boundary of positive infinity, you need the closed parentheses there. Also, the range is all real numbers, and so we would show that with interval notation the same way. On this one, we have y equals x squared plus 3. Let's look at an xy chart. And let x be negative 2, negative 1, 0, 1, and 2. When x is negative 2, we have negative 2 squared plus 3, which is 7. When x is negative 1, we have negative 1 squared plus 3, which is 4. When x is 0, we have 0 squared plus 3, which is 3. When x is 1, 1 squared plus 3, which is 4. And when x is 2, 2 squared plus 3, which is 7. We look at the graph on this. We have a parabola. And we can see that this is a function. The domain is all real numbers. So with interval notation, we have negative infinity to positive infinity. The range, we can see that we don't start our points until here when y is equal to 3, and then we go on forever up. So our range includes 3, and we use a bracket to show that we're including 3, and then we go up to positive infinity. Now this one is a little bit different. We don't have y equals, so let's sub in numbers for x. If x is 1, we have y squared equals 1 plus 3. Y squared equals 4. Now we need to square root both sides. But remember that when you square root, you need plus or minus. And the square root of 4 is 2. So when x is 1, y is plus or minus 2. Now this indicates that this is not a function. Because remember that in order to have a function, for every x value, you have only one y value. So we don't have a function. And let's go ahead and do some more numbers. If x is 0, we have y squared equals 0 plus 3. Y squared equals 3. So y equals plus or minus root 3. And let's let x equals negative 3. When x is negative 3, we have y squared equals negative 3 plus 3. Y squared equals 0. Now there's no plus or minus on 0, so y equals the square root of 0 is 0. And then if we tried x equal negative 4, we'd have y squared equals negative 4 plus 3. Y squared equals negative 1, and this is not going to happen because the square root of the negative 1 is imaginary, so this is our smallest y value. Let's look at a graph. The graph of this relation looks like this. And we can see that our domain starts at negative 3. That's the smallest value we can have because any smaller will get an imaginary number. So negative 3, and then we go forever to the right. So negative 3 is included in the domain. And then we go on forever to the right. Now our range, it looks like we go forever down, negative infinity, and we go on forever up. So our range is all real numbers. We show that with interval notation this way. And on this one, we don't have y equals again, so let's do an xy chart. And this time, since we're doing an operation on y, let's sub in values for y and see what x is equal to. So if y is positive 2, negative 2, positive 1, negative 1, and 0. Let's try those. So the absolute value of 2 we know is 2. The absolute value of negative 2 is also 2. The absolute value of 1 is 1. The absolute value of negative 1 is also 1. The absolute value of 0 is 0. So we can see that this is not a function. Since we have two values for y for this given value of x. Let's look at the graph on this. So our graph for this relation looks like this. So our domain we can see from our graph. We're going to start at 0 and then go on forever in the positive infinity. So 0 is included. And we go to infinity. Our range goes forever down and up. So that's all real numbers. Now this one is an inequality. Whenever you have an inequality, you're not going to have a function. Look at that in a minute. If we look at the line y equals negative x, we know that that is a line at a 45-degree angle. Well, if we want y greater than or equal to negative x, then we can look at the point 2, 3, and if we check that out with our inequality, our y value is 3, so we'd be saying 3 is greater than or equal to a negative, and then x is 2. And this is a true statement. So any point that's up here above this line is going to be in the graph of this inequality. So anytime you have shading like this, it's not a function. Now, as far as our domain and range go, because of the shading and because of these arrows showing that we go left and right forever and up and down forever, our domain is a set of all real numbers, which we'll show with negative infinity to positive infinity. And the range is also all real numbers, from negative infinity to positive infinity. Our last example. On this one, we have a restriction on the domain. Anytime you have a fraction, the denominator cannot be 0. So negative 2, if we put that in for x right here, we would have a 0 in the denominator. So our x cannot be negative 2. Now let's look at some points. I'm going to use negative 6, negative 5, negative 4, negative 3. Can't use negative 2. So negative 1, 0, 1, and 2. So here we have 3 divided by negative 6 plus 2. That is a negative 3/4. This one is 3 divided by a negative 5 plus 2, which is negative 1. 3 divided by a negative 4 plus 2, which is a negative 1.5. 3 divided by a negative 3 plus 2 is negative 3. And then 3 divided by negative 1 plus 2, this is 3. And this one's 3 divided by 0 plus 2, it's 1.5. And 3 divided by 1 plus 2, which is 1. And here we have 3 divided by 2 plus 2, which is 3/4. So our graph on this one looks like this. Notice that we'll never cross the x-axis either, because in order to do that, this whole fraction would have to equal 0, and that won't ever happen. So we also have this asymptote here, the horizontal line y equals 0. And then on this side we have a curve that looks like this. So this one is a function. The domain is going to be all real numbers except x is not equal to 2. So the way we show that with interval notation is from negative infinity to negative 2, so we're not going to include the negative 2, union with, and then we'll pick it back up on the other side of negative 2 and go to positive infinity. Our range is all real numbers except for y equals 0. So negative infinity to 0, union 0 to infinity.